Before you even feel the gravity, your eyes would betray you. As you approach a black hole, the universe doesn't just get dark, it gets weird. That halo of light you see, that's the Einstein ring. It's starlight from behind the black hole being bent around it like a cosmic lens. And in the center, the shadow. Absolute, terrifying nothingness. But here is the twisted irony of astrophysics. You actually have a choice of how you want to die. Most people think all black holes kill you the same way, instant crushing. Wrong. Your survival depends entirely on the size of the monster you choose to visit. And contrary to common sense, the smaller ones are actually the meanest. Let's say you pick a small one, a stellar mass black hole. Bad choice. Before you even reach the shadow, you encounter tidal forces. Because the gravity source is so concentrated, the pull at your feet is infinitely stronger than the pull at your head. You don't just fall, you stretch. Scientists with absolutely zero chill call this process spaghettification. You are compressed horizontally while being pulled vertically. You literally become a tube of biological toothpaste being squeezed into the void. In a small black hole, this happens before you even enter the event horizon. You are dead before you even enter the darkness. So let's try the supermassive black hole instead, like Sagittarius A at the center of our galaxy. Surprisingly, this is the safer bet. Because the singularity is so far away from the edge, the tidal forces here are gentle. You could actually cross the event horizon, the point of no return, completely alive. You wouldn't feel a thing. To understand why, we need to clear up a massive lie. Black holes aren't just heavy, they are dense. Imagine crushing Mount Everest into a sugar cube. That's the kind of density we're talking about. This creates a gravitational pull so strong that not even light can escape. But once you cross that line, reality splits in two. This is where Einstein's ghosts come out to play. To your friend watching from a safe distance, you never actually enter the hole. They see you slow down as you approach the edge. Your image fades to red, a phenomenon called gravitational redshift, until you just freeze there. To them, you were a ghost frozen on the edge of eternity. To you, you just fell right in. Inside the horizon, time and space switch roles. Moving forward in time literally means moving toward the center. And if you look back over your shoulder, you might see the external universe in fast forward. Light falling in behind you gets energized by gravity, shifting to blue, then violet. You're essentially watching the future history of the galaxy crashing down on top of you. But don't get too comfortable. Even in a supermassive black hole, gravity eventually wins. Theoretical models suggest that deep inside, tidal forces might switch direction. Instead of spaghetti, you get pancake detonation. You are flattened violently, triggering a release of thermonuclear energy from your own atoms. So it's either spaghetti or pancake. Pick your dinner. And we haven't even mentioned the heat. Most black holes are surrounded by an accretion disk, a carousel of gas spinning at nearly the speed of light. Friction heats this matter to millions of degrees, so in reality, you'd probably be microwaved by X-rays long before you ever had the chance to turn into pasta. Why does this matter? We aren't planning a vacation there, but studying these monsters unlocks the architecture of reality. Using the James Webb Space Telescope, we are now using the gravity of these massive objects to map dark matter, the invisible scaffolding that holds our universe together. We used to think black holes were just destroyers. Now we know they are creators. They anchor galaxies. Without them, the Milky Way might not exist, and neither would we. By listening to the gravitational waves of their collisions, we are finally hearing the soundtrack of the universe. But what lies at the very bottom? General Relativity predicts a singularity, a point of infinite density where physics simply breaks down. Quantum mechanics says that's impossible. It is the edge of knowledge, a place where and when lose all meaning. If you fell in, your information would be lost to us forever. You would become part of the mystery. The universe doesn't care about your curiosity, but gravity certainly cares about your mass. So next time you look up at the night sky, remember, it's not just empty space. It's a hungry, beautiful, terrifying machine. Thanks for watching.